morning, everyone. I am Ma'am Cheska Balegram, or for short, you can call me Ma'am Ches. And we are going to discuss a topic that you learned from the previous lesson. And your topic was called derivatives, right? And now, we are going to discuss something that is connected to derivatives. For our lesson today, it is going to be anti-derivatives. So let's assess first this first word. From the word anti, this means is that you are opposed. Or from the other word, you are opposing. And if you are opposing from derivatives, this just means that you are going to get from the third derivative, from the second derivative, from the first derivative, and finally, the capital F of x is called antiderivative. So now we are going to define what the meaning of antiderivative is. So here, our first objective is we are going to define what antiderivative is. Since I haven't explained to you the full definition of antiderivative, an antiderivative is just a mathematical function I'm going to charge that word, but this is function, a mathematical function that reverses the process of differentiation. This is the meaning of antiderivatives. And when we go to the right, here we can observe that we are finding the antiderivative. And the process is called integration. And when we go to the left, the process is called differentiation. Because from the from our first derivative, we are going to define what antiderivative is. Earlier, since I haven't fully explained to you what the meaning of antiderivative, this is our antiderivative meaning. A mathematical function, I just shortened the words, but that's function, that reverses the process of differentiation. Here I illustrated this earlier. And when we go to the right, the process is called integration. And when we go to the left, that is differentiation because we are finding the derivative. Going left and going right, we are finding the antiderivative, and that is called integration. So we have done our first objective, and now let's move on to our second objective. We are going to know the difference between derivative and antiderivative. Antiderivative and derivative is just two opposites actually, but they serve the same function. And here we have the second objective. Know the difference between derivative and antiderivative. So I'm going to tell you the difference from both of them. Actually, they are too close. And here we have the second objective, which is know the difference between derivative and antiderivative. I am going to tell you the difference of derivative and antiderivative. They are two important concepts in calculus, and they are both closely related to each other, but they both serve different purposes. Here, this small f of x, this is called the derivative. Meanwhile, the capital F of x, this is antiderivative. Which you can see over here, this is small f, and this is the capital F. Did we know the difference between derivative? I sure did. Now, we're going to move on to the steps of finding antiderivatives. So So let me erase everything from the board, anything unnecessary. Okay, so here I just rearranged the board so we can have it cleaner and nice board that we can work on. And actually, before we head to the steps of finding antiderivative, I want to tell you that antiderivative is also called indefinite integral. If you have no idea what an indefinite integral is, here I am going to illustrate to you. This symbol, I'm sure you're not familiar with this symbol, and that symbol is actually just called the integral. And then here, we have the f of x equals dx now. F of x is equal to dx of x, and then dx. Here, this is an indefinite integral. Why? So let's have another example. And then we have the limits of integration. We have an upper limit and we have the lower limit. And this is called definite integral. This is called indefinite integral, which is antiderivative, because we are just going to find the integral of x times dx. So to differentiate the two, let's just look for the limits of integration of the upper and lower limit and the full number here. So now, let's move on to finding the steps of how to find the antiderivative. From the first step is that we are going to identify the function to be integrated. And from the second step, we are going to use basic integration rules. We are going to talk about that later on, and we have the power rule, which we will be discussing later. Exponential, we actually haven't included this one, since we are only going to focus on 3 rules. And then for the last rule is that we are going to add the constant of integration, which is just letter C. And this constant of integration, which is the letter C, we are always going to add this to our final answer. And now we have the first step, the second step, and the third step. Now I am going to discuss the antiderivative rules. So for the first rule, we have 0 multiplied to dx is equals to c. Why? Because when we multiply 0 to x, it will just end up equal to 0. our constant multiple. Oh, sorry, this is our constant multiple. And then this is the sum and difference rule. And then here, this is just constant. Because we are only going to find one constant of that. Sum and difference, that is called sum and difference because it's a sum and this is the difference. Constant multiple because we are going to put the constant outside. And then for our last rule, which is widely used in every equation, let's put it here, that will be x raised to n multiplied by dx will be equal to x raised to n plus 1. And copy this here, that will become n plus 1. So if you don't know what this is called the power rule. Now we have our first rule, which is when we multiply 0 to x, it will only become the constant of integration. And we have here the constant, which is just defined as k, which we will multiply with x, and add your constant of integration. And your constant multiple, sum and difference, and lastly, the power rule. So those are the basic antiderivative rules. And now, our third objective, we have learned the type of rules of finding antiderivative. Now we are going to head on how to actually find the antiderivative using these antiderivative rules or the formulas. Now before we actually head on to the actual lesson of finding the derivatives or the antiderivatives, we are going to go back from your previous lesson and I'm going to give 3 examples of a function that we are going to derive. So for our first example, we have 3x squared, 3x cubed plus x squared and plus y. If we are going to derive this function to its first derivative, we are going to multiply here the constant to the exponent. 3 times 3 is 9, and minus 1 to the exponent, that will be 2. 1 times 2 is 2. Copy the symbol. 2 minus 1 is 1, and we are not going to copy the function anymore. So this is going to be our first derivative, right? And now we are going to find the second derivative of the first derivative. 9 times 2, that would be 18. 2 minus 1, that is 1. Or we just don't have to write that down. And then this would be only 2. Now find the third derivative, that would be 18 only. And we don't have to add the constant. And now, what does this derivative have to do with our lesson antiderivatives? Here we are going to take the second derivative and we are going to use the power rule. We are going to write it as the integral of the second derivative dx, and that would be equal to the first derivative. So how does this happen? So let's try to solve it. And that would be second derivative, and now we're going to use the power rule. Here, x raised to n plus 1, that would be 18 raised to x, our n, this is 1, plus 1, and then we are going to copy this one and put it in our denominator. And then since we have a constant, we are going to copy the sign, plus 2, and then add dx. For the second step is that we are going to add this, the exponent, and the denominator. That will be x squared, and then over 2 plus 2x. Since these numbers are divisible, you can just simplify, and that would be 9x squared minus 1 is 1. We don't have to write that down. And this will be 2. Don't copy the constant anymore. That is not needed. And then the second derivative will be only 10. Now we are going to here assess that this is too complicated to solve. So we are going to solve the first derivative back to its original function. So here let's write. Here let's write the first derivative, and that would be equals to the antiderivative or the original function, which is this one. We are going to copy our first derivative, 10x 1 plus 1. Copy this one again. 1 plus 1. And then our constant is 2. Copy the sign and add x. And then just add the exponent, which is 2. And then the denominator, copy this one, and divide. That will be equal to 5x squared plus 2x. And then our third step is add the constant of integration. So this looks alike to this one. So that is the recap of finding the derivatives and a short examples of how to find the antiderivative of a derivative using the power rule. Because earlier, as I shown in the video, the third derivative to the second derivative, to the first, and to the antiderivative, what we did is we derived first, and then we went from the process of differentiation, and then we did the process of integration, which is finding the antiderivatives, which is we went left. So now, for our next lesson, let's move on to finding the constant. So now we're going to find the antiderivatives of polynomial and binomials. So you may ask, what is a polynomial? And binomial. A poly consists of 3 or more. A binomial, coming from bi, means 2. So I have here 3 givens that I will be discussing. Una, f of x equals negative 4 x squared minus 9x minus 1. 1. So that x squared minus 1 by 1 x 2x plus 2. Hindi sa C. I mean 2x plus 3. Yun lang. Walang square din 2x. Wala. So here are the 3 given functions. I have given A, I have given B, and I have given C. So let's do first our first given. So here we are going to identify the function to be integrated. This is the function that we have to integrate, and we are going to use basic integration rules. As I have discussed earlier, I put a list of antiderivative rules here. And now we are going to use, from this given function, we are going to use the power rule, which is x raised to n. Dx is equals to x n plus 1. And just copy that one, n plus 1. And we are going to integrate this function. That would be negative 4. And then copy the exponent, which is 2. And just copy that 1. And then 9x negative 9x, that will be 1 plus 1. Copy into the denominator. And then we have here negative 1. We don't have to write it down, so it would only be negative x. Now we're going to add the exponent. That will be 3. 3. And then 9x squared. 2 minus x. This is acceptable. But we have to make it like this. That will be negative 4 over 3. And then separate the x cubed from the 4 over 3. That will be x cubed minus negative 9 over 2x squared. And then minus x. And then our third step is to add the constant of integration plus c. So this is our antiderivative of given a. Now let's move on to given b. Here we have 11x squared. Just copy that. And then add 1 to the exponent. Copy that to the denominator. Minus 121 x 1 plus 1. We don't have any constant, so we would only write it as 1. Now we're going to add that again. Minus 121 x squared. And then we're going to simplify like what we did earlier. Separate the fraction and the exponent. That would be 11 over 3 x cubed minus 121 over n exponent plus c. This is our antiderivative of given b. Okay na. Next. And now let's move on to the binomial. Consider this only 2 variables, 2x and plus 3. Copy the 2x, and then 1 plus 1, and 1 plus 1. Since 3 is our constant, it will be positive 3x. Like that. And then just add again. Copy the constant 3x. And then we can cancel this, and we will be only left with x squared. So we will be left with x squared plus 3x plus the constant of integration. And this is our antiderivative for given c, which is a binomial. So now let's head on to finding the antiderivative of constant. So now let's remove this one, since we'll be moving on to find the constant of a single variable, which is k. And we work with x equals to a plus c. And don't forget the x there. Now we'll be heading on to using this antiderivative rule, which is the constant. And we have here 5 givens. Our first given would be 5dx, 7d, 6dz plus 4 bracket dz, dds, 5d. So now, what we're going to do, as I said on the antiderivative rule, is that we will
I am Charlemagne and I am here to teach you all about the power rule of integration. So before that, let's have first the formula for the power rule of integration, which would be the integral of x raised to n dx is equals to x raised to n plus 1 over n plus 1 plus c, where n is not equals to negative 1. So that is our formula for the power rule of integration. Now, let's have our first example. Let's say we have the integral of x cubed dx. Now, if we take a look at our formula, we can see here that our n is our exponent. So in this case, our n would be the 3. So x cubed. Then we can see that we added a plus 1 to our exponent. So we'll do the same thing. Plus 1 over 3 plus 1. The same thing for our denominator as well. Now that is going to equal to 3 plus 1 equals to 4. 3 plus 1 is equals to 4. Now you just add a plus c, and there you have your final answer. Now let's move on to our second example. For our second example, we have the integral of dx over x to the 4th. So what we can actually do here with our denominator is we can actually switch it to our numerator. So what will happen is, since we're changing its positions, we're also going to be changing its sign. So it will become from x raised to positive 4, it will become x raised to negative 4 dx. And now we can proceed. So we'll have x raised to negative 4 plus 1, and then we'll do the same thing for our denominator. It will become negative 4 plus 1. Negative 4 plus 1 is equals to negative 3 plus c. Now, this can either be your final answer. If you don't want to have a negative numerator, what you can actually do is you can bring down the exponent, the x raised to negative 3 to the denominator. So what will happen is you'll have a 1 for a numerator, and then 3x cubed plus c. So this will be your final answer. Good day, learners! It's me again, and I am here to teach you about another method called the constant multiple rule. So again, let's have first the formula for the constant multiple rule, which would be the integral of c f of x dx. Now the c right here, this is our constant term. And what we're going to do with our constant term is that we're going to take it and switch its positions. We're going to bring it down right over to the left side of the integral sign. So it will become c, the integral of f of x dx. Now let's have our first example. Let's say we have the integral of 8x to the 4th dx. Now in this case, our constant term would be 8. This is our constant term. So we're going to take it and place it right over to the left side of the integral sign. Integral of x to the 4th dx. And now we're going to multiply. So we have 8 times x to the 4th plus 1 over 4 plus 1 plus C. 4 plus 1 is equals to 5. So 8 times x raised to 5 is 8x raised to 5. 4 plus 1 is also equals to 5. Since we can no longer simplify it, we'll just add a plus c, and then there you have your final answer. Let's move on to our second example. So let's say we have the integral of 4 times the square root of u du. So again, we'll take our constant term and then place it over to the left side of the integral sign. So for the integral of u, now what we can actually do here with our radical sign is we can express it as 1/2. Since its nth root is 2, so that will become our denominator. Now we'll just go up with the u. And now we can multiply. So 4 times u raised to 1/2 plus 1, 1/2 plus 1 plus c. Now, this is originally written as 1/2 plus 2/3, which originated from our denominator. Since 2/2 is equals to 1, we wrote it down as 1. But the answer for this would be 1 plus 2 is equals to 3, and then you just copy the denominator. So we'll have 4u raised to 3 over 2 over 3 over 2 plus c. So now what we're going to do is we're going to multiply the 3 over 2 by its reciprocal, which would be 2 over 3. So it will become 4u raised to 3 over 2 times 2 over 3. So 2 times 4 is equals to 8 u raised to 3 over 2 over, then you add the plus c, and there you'll get your final answer.
Good day everyone, my name is Ronver James Escolcoller. You can call me Sir Ronver. So right now, I'm going to teach you guys the other part of power rule. Since Ma'am Chess and Ma'am SM already teach you guys the definition of the antiderivatives and the function of power rule, so right now we're going to talk about the radical. So since you guys already know the antiderivatives and the power rule, we're going ahead to our example. So we're going to have here the cube root of x dx. So right now, so the first thing we can do is we're going to put the indefinite integral sign and our cube root x dx. So after that, we're going to multiply the 3 from the exponent here. So our x already have the 1 exponent. So since it is 1, it is invisible. So we're going to multiply it from our exponent, so or variable. So we're going to have here the x raised to 1/3 plus c. Next thing is we're going to perform the power rule. So Ma'am Cheska and Ma'am SM teach you guys the x and plus 1. So right now, x plus n plus 1, we're not going to follow that function since we already have here the 3. So we're going to do guys here is we're going to plus the 3 in our n or in our exponent. But same thing in power rule, this part is still going to be our denominator. Don't forget the plus t. After that, we can perform the power rule. So we have here the 1 plus 3 is 4. So since our denominator is same number, so we're just going to copy that one. Same here, same in our denominator, we're going to have here the 4, 3 plus c. Since we have here now, we're going to transfer our denominator to the side so we can multiply it. So since we're going to transfer it, our denominator, we're going to change it, the position. So we're going to have here the x 4, 3 multiply by 3 over 4 plus c. After that, we're going to multiply it. So here, x raised to 4 over 3 times 3 is 3x 4 over 3. 4, so our function 1 is already have a over 1. Since it is over 1, we're not going to put that. So since we know that we have a over 1, so 4 times 1 is 4 plus c. After that, we're going to separate our whole number to our variable. So we're going to have here the 3 over 4 multiplied by x raised to 4 over 3 plus c. So after that, we're going to divide the 4 over 3. So we're going to divide it. So we're going to have here the 4, 3 cube root of 3 x x4 plus c. Since are given, we can still simplify it. So we're going to get the less common factor, or the LCM. Or we have here the 3 over 4 x3 x plus c. But how sure are we that our already simplified function is correct? So as you can see here, we have the 3 over 4 x3 then x plus c. 3 times, so we're going to multiply it. X raised to 3 then to our x. So we're going to have the 3 over 4 x4, or simply we're not going to add that. So as you can see, it is the same. So in that example, we can say that our answer is correct. So after that example, we're going to have another example so you guys will understand it more. So let's try other example. So we have here, we have here 4th root of x dx. So what was our first step? Put indefinite integral. So we have here 4th root of x dx. So the first step that we need to do is multiply our exponent. So equal x. So 4 is we're going to the denominator plus c. Next step, we're going to apply the power rule. So we're going to use the 4. So we have here x 1 over 4 plus 4 over 4 over copy this one. 4 plus 4 over 4. Next is we're going to simplify it. So we have here x 5 over, since we have a different, no, since we have here same number, so we're just going to copy it. So we have here 4 over, just like that, 5 over 4 plus c. Next, we're going to transfer our denominator to the side and change the position. So we have here the x 5 over 4 times 4 over 5, since we changed the position. The next one, no, plus c. Next, we need to multiply it. So 4 times x raised to 5 over 4, we're going to have a 4x 5 over 4. Next one. So our variable is over 1. So 5 times 1 is 5 over, no, plus c. After that, we're going to separate the whole number from our variable. So we have here 4 over 5 times x 5 4 plus c. Right after that, we're going to divide the 5 to the 4. So we will have our 4 over 5. Then we're going to have here the 5 plus c. Since we can simplify it, so we need to simplify it. 4 over 5 x 4 5 plus c. So will be the final answer. So that's how you do the other part of power rule, which is radical. So I hope you learned something. So the last topic that we're going to tackle is sum and difference. Speed up nyo na lang ito. Sum and difference rule. So in this rule, we're just going to have a two given A and given B. So our first given is addition or sum, and our second given is subtraction or difference. But right now, I'm going to give you first the formula for our sum and difference. So that would be indefinite integral of bracket function f of x plus and minus g of x bracket dx is equal to function of f of x, no, indefinite integral of f of x dx plus or minus g of x dx. So as you can see, it is different, okay, because in our first function, it is combined. As you can see, our first and second function is combined. And for our second one is separated. As you can see, the two function is separated. So now, let's continue to solve our first given, which is our sum. So our first given will be indefinite integral of 12x squared plus 2x dx. So the first step that we need to do is we need to separate the two function and get their integral. So the reason why we're going to separate them, because we need to get their integral separately. And our constant or our whole number is going to move before our integral. So here, we're going to have here the 12 indefinite integral of x squared x dx plus 2 indefinite integral of x dx. After that, we can now perform the power rule. So we're going to have here the 12 times x. 12 plus 2 plus 1 is 3 over 3. Next one plus 2. 1 plus 1 is 2 over 2 plus c. After that, we can now multiply our whole number to our variable. So right now, 12 times x raised to 3 is 12x 3 over, since our whole number is over 1, 1 times 3 is over 3 plus our second function is 2 times x squared is equals to 2x squared over 2 times 1 is equals to 2 plus c. As you can see, our first and second constant or variable or function is, we can still simplify them. So right now we're going to simplify it. So I'm just going to remove that first. So we need to get their LCM. So we can simplify them by dividing them both to the 3. So 12 divided by 3 is equals to 4x3 over 3 divided by 3 is 0. So we're not just going to put that 1. Okay, or 1 rather. Plus, since it is a same number, so we're just going to cancel it. X. So this is a plus, okay. So don't get confused. X 2 plus C. So this answer is our final answer. Therefore, we can say that our indefinite integral of 12x2 plus 2x dx is equal to indefinite integral of 4x3 plus x2 plus c is equal. As you can see, our formula right here is the same. So we can say that this is our final answer. So this is only in our sum. So we still have the difference. So right now, let's move on to the difference. So right now, let's move on to the different given. So our given here is indefinite integral of 2. Our variable is t raised to 2 minus square root of 3 t 3. So as you can see, we have here the radical, same as the radical rule in our power rule. So the first thing first is we need to get the squared first. So we're going to have here the integral. We're going to have here the indefinite integral of 2 t2 minus, so we have here 2 since it is a square root. So I'm just going to put 2 so you guys don't get confused. So we have here 2 times 3 is simply, we're just going to have a 3 over 2, just like in our power rule. The second one is we can now separate our two function. So we're just going to move our whole number before the integral. So we have here 2 indefinite integral of t to d t, or no, baliktad. No, dt minus 3 indefinite integral of t 3 over 2 dt. Now we can perform the power rule. So we have here the 2 times 2 plus 1 is equal to 3 over 3 minus 3. So just like in our power rule radical, we're going to use the 2 as our plus. So we have here plus 2 over 2 and over 2 over 2. So we're just going to have here the 5 over 2 over 5 over 2 plus c, our constant. After that, we just need to multiply it one by one. So we're going to have here the 2 times t raised to 3 is equals to 2 t raised to 3 over, our whole number is over 1. So 1 times 3 is equals to 3 minus 3 times t over, 3 times t raised to 5 over 2 is simply 3t raised to 5 over 2 over, so our whole number is over 1. So 1 times 5 over 2 is 5 over 2. So since we have here our denominator as a 5 over 2, we need to get rid of this one. So just like in our radical rule, in power rule, we just simply need to copy this one. Okay, so we have here 2 3 over 3 minus, so I forgot the plus c. So first we need to transfer it to the side to multiply, and we need to change the position of these two. So we just simply have the 5 over 2 times 2 over 5, of course the plus c, and after that we need to multiply it now. So just like what I have said, we just need to copy this one minus 3t raised to 5 over 2 times 2 is 6t 5 over 2 over 1. 1 times 5 is 5 plus c. Since we no longer need to simplify them, so this will be our answer. But of course, not the final, because we need to have a conclusion. So therefore, we can say that the integral or indefinite integral of 2t raised to 2 minus square root of 3t raised to 3 dx or dt is equal to indefinite integral of 2t raised to 3 over 3 minus 6t raised to 5 over 2 over 5 plus c is equal. So this will be our final answer. So as you can see, sum and different rule is almost the same. The only difference is the sign, but the process is almost the same. As you can see, the difference between the sum and difference is of course the sign only, but the process is the same. So that's how you do the sum and difference. Thank you.